Alright, today we're going to take a look at what we call sequences and series. Now, we'll talk more about series tomorrow, but today we're going to take a really focus on a sequence. And really all a sequence is it's a ordered set of numbers. It's an ordered set of numbers that follow a pattern.
The Avid site meeting will be in room L226.
Okay.
Avid site meeting
So,
will be in L226.
now,
Thank you.
basically what it is, you can have some little function a sub n, where a sub n is our term. It's the term. And the n is what we call the term number. Now, what we're going to talk about for the beginning is how do we generate terms of a sequence. That should be a term. So, we want to generate the first 5 terms of these following sequences, starting with n equals 1. So, if I let n equal 1, that's going to give me a sub 1. And if I just plug it in here, I get 3 times 1 plus 1, which is, of course, 4. Now, we don't have to write down the n equals every time. If I let n next one, I want the first 5, so there's 1. Let n equal 2, we get 3 times 2 plus 1. And that's going to give us 7. A sub 3, the next term, 3, 1, 2, 3. 3 times 3 plus 1, and that gives us 10. A sub 4, 3 times 4 plus 1, which gives us 13. And the last one, a sub 5, 3 times, let n be 5, plus 1, we get 16. And there's our first 5 terms, 4, 7, 10, 13, 16. And we generally write them in order, 4, 7, 10, 13, 16. Let's try the next one. Well, let's find our first term, a sub 1. Well, let n be 1. We get 1/2 to the first, and that's pretty easy, 1/2. Let n be 2. 1/2 squared. Now that's pretty easy. 1 squared is 1, so we get 2 squared is 4. n be 3, we get 1 over 2 cubed. And we get 1 on top. 2 cubed is 8. Ran out of room. Let n be 4. We get 1/2 to the fourth, which is 1 over 16. And a sub 5, to get the fifth term, very easy, 1/2 to the fifth, which is 1 over 32. And list them out. 1/2, 1/4, 1/8, 1/16, 1/32. And there we go. So what I would like you guys to do is try number 3 real quickly on your own, and then we'll go ahead and do number 4. Now, number 4 is kind of a neat one because, take a look here, there's no n I'm going to plug it into. So if I do a sub 1, it's 3. A sub 2, what do you suppose that's going to be? Well, there's no n to plug the 2 in, so I get 3. A sub 3, 3. A sub 4, the fourth term, that's what I'm saying. I want the fourth term is still 3. The fifth term, still 3. So we list them out, 3, 3, 3, 3, 3. And there's your sequence. All right, let's try 5 here. Okay, let n be 1, a sub 1, 3 to the first over 2 to the first, we get 3/2. Let n be 2, 3 squared over 2 squared, I get 9 over 4. Let n be 3, to get the third term, we're going to take 3 cubed over 2 cubed, and we get 27 over 8. And let's plug in 4 now. The fourth term, a sub 4, 3 to the fourth over 2 to the fourth. Now we're going to have to deal with 3 to the fourth quite a bit. That's easy. It's 81, and 2 to the fourth is 16. But the trick one is the fifth one. 3 to the fifth over 2 to the fifth. Now the bottom is 32. That's pretty easy to do. But to get 3 to the fifth, again, we're going to see this one quite a bit. Just take the 81, multiply it by 3, and you get 243. And here are your 5 terms, right there. Very easy to do. All right, so let's try number 6 here. Ready? So let's try number 6. Let n be 1. Be careful. This is 1 over 3 to the fourth, which is just 2 minus 1/3. Notice I'm not going to reduce it. 2, Find the second term, 2 minus 1/3 squared, which becomes 2 minus 1/9. The third term, 2 minus 1/3 cubed, 2 minus 1/27. Don't worry about reducing it. The fourth term, 2 minus 1/3 to the fourth, 2 minus 1/81. The fifth term, 2 minus 1/3 to the fifth becomes 2 minus, again, 1/243. Now, what's really kind of cool about this one, notice what's happening. The 2 stays the same, but the fraction's getting smaller and smaller and smaller. Eventually, if we let n get really big, like let's say infinity, let's let this term, the infinity term, what's going to happen to the value of our term here? What is the term approaching? What is a sub n approaching as n goes to infinity? Now we spend a lot of time on this on calculus and something else we're going to be doing later on in here. All right. So what I would like you guys to do is well, let's do number 7 together. I guess that's kind of a tough one. Get the first term. Let n be 1. We get the cube root of 1, which is just 1. 2. We get the cube root of 2. Now, where did I get the cube root? That's that 1/3 power. The third term, the cube root of 3. Please don't say that's 1. The fourth term, the cube root of 4. And the fifth term, the cube root of 5. So we get 1, cube root of 2, cube root of 3, cube root of 4, cube root of 5. So what I would like you guys to do is to do number 8 as well, and see if you can try to figure out number 9. We're looking for the 12th term of the series. I'll give you a hint. That's n. Okay, so try to do numbers 8 and numbers 9, and then let's go on to the next section, okay? All right. Now, for the next section, again, we're asked to this time sketch, okay, of the first 5 terms of a sequence. This is like plotting points. That's all it is. It's plotting points, where n are your x values, and your a sub n are your y values. Okay? So very easy. If I get the first term, a sub 1, 1/4 times 1, 1/4. The second term, 1/4 of 2, which is 1/2. The third term, 1/4 of 3, which is 3/4. The fourth term, 1/4 of 4, which is 1. And to get the fifth term, 1/4 of 5, which is 5/4. So if I want to sketch it, well, what's my smallest value? 1/4. I'm going up to 5/4. So if I sketch this, here's my n's, here's my a sub n's. I want to see what this looks like. Now, it should be linear, because if you think of it as a function, y equals 1/4 x. So 1, 2, 3, 4, 5. Now, when I graph it, I don't want to graph 1, 2, 3, 4, otherwise it would be kind of hard. I'll go every half. 1/2, 1, 1.5, 2. So at 1, we're at 1/4. Halfway there. At 2, we're at 1/2. At 3, 3/4 is between 1/2 and 1. At 4, we are at 1. And at 5, we're at 5/4, which is between 1 and 1.5. Do not connect the dots. Don't connect. These are what we call discrete points, okay? To connect them, you will mess up there, okay? Be careful. All right, let's try one more before we go to a break in the part 2, okay? Find your first term. Very easy. 1/, let n be 1. 1 plus 1, we get 1/2. Get your second term. 1/2 plus 1, 1/3. Get the third term. 1/3 plus 1. If you notice, I'm just plugging them into my n's. Get the fourth term. It is that easy to do. 1/5. And the last one, the fifth term, 1/5 plus 1, we get 1/6. So if I sketch this one, now if you notice, this graph is a rational function. So we should get something that looks rational, at least for a little bit. 1, 2, 3, 4, 5. And if I graph this, be careful, 1/2 is my biggest, I go down to 1/6. So I'll go here at 1/2, okay? And I'll put 1/4 in the middle, okay? So at 1, we know we're way up here at 1/2. At 2, we're at 1/3, which is a little bit more than 1/4. At 3, we're at 1/4. At 4, we're at 1/5, puts us below. And at 5, we're at 1/6. So it's getting smaller and smaller and smaller. And you can kind of see it curve a little bit. You're not going to get this perfect by any means, but it gives you an idea at least. All right, so what I would like you guys to do, we're going to do number 12, but see if you can try number 12 on a calculator, use your tables, and then go on to number 2, and we'll explain how to do this one.